Hello, welcome to Math Freak channel. Okay, so today we're just gonna go over the concept of percent error and how to calculate that. Okay, let's start with that. Uh, how do you find the percent error, or what exactly is it? So basically, let's say you're in a lab, most probably chemistry lab, doing some experiment with percent of oxygen, percent of hydrogen, or whatever. Um, To calculate the percent error, we always have to have a theoretical value. Um, in our case, we're going to call it T, which is predetermined by your professor or, some scientist uh, back in. Okay, so let's just start up with the simple problem. Okay, let's just say that we're giving T the theoretical value, which is 100, and when we ran the lab, we got the actual value of the lab, so we're just going to call that an A, to be equals to 78. So just by looking at that number, we can say that should be off by 22 because the difference is 22. But to actually find the experimental value, we're going to use this formula. T, which is theoretical value, minus the actual value, which is A, over theoretical value, times 100. That is because we want to convert that into percent. So whatever we get is the answer. Okay, let's use those numbers that we are given using the formula I just showed. Okay, so theoretical value is given as 100 and then the actual is given as 78. Let's just plug in Chuck. So 100 minus 78 over 100 and times 100 for the percent. We just got to remember that whole thing is under absolute value. So because the percent error cannot be negative or positive, or it doesn't have a direction, so we always have to put it as an absolute value. In our case, we got 22%. Okay, now let's just look at a bit more complex problem. Let's just say the given value we have for T is 71, and then the actual value is 62. Now that looks more realistic to me. Let's just say the amount of oxygen in a water we have is 62%, and then the hydrogen is 1%, the rest of the percentage out of the 100 or whatever. So if you plug in Chug into the formula, which is T minus A over T times 100, and we got to make sure this is under absolute value. So this is going to be 71 minus 62 over 71 times 100. Let's just forget about the absolute value at this time. So our answer will be equal to 12.6%. So that was in whole numbers. Let's say the experiment is on smaller number that are smaller than 1, or probably even smaller than half. You want to say that They're in decimals. So for this problem, we will say that our theoretical or predetermined value by our professor is 0.22. And our actual value that we got when we ran our experiment is equal to 0.24. Now, if we don't use the absolute value, let's just calculate that. 0.22 minus 0.24 over 0.22 times 100. Now, if we don't use the absolute value, we get negative 9.1. Negative 9.1. Sorry, that's a negative sign. To avoid that, we have to use the absolute value to take away that sign. So let's just put the absolute value around this. It will become 9.1%. Thank you. Have a good day.